students, in this presentation I shall be talking about the metabolism and its relationship in the organization of the human work. We know that the productivity of any organization to a great extent depends upon how effectively the different resources are being used in getting the desired job done. These resources are mainly the man, material, machines and the capital power which is available with the organization. In method study, we to a great extent focus on the effective utilization of the manpower in such a way that the given job is completed in the less time, and so that an operator is able to complete the job earlier and able to give the higher output for increased productivity of the organization. The output of the worker depends upon how much energy he is consuming in a given job and how long he can work without need of any break. Whenever work is carried out by the worker, some amount of the energy is consumed in carrying out the work. The energy consumed in carrying out the work or energy delivered by the worker to carry out a given job is known as work cost, and which energy is continuously delivered by the worker in while carrying out the job. And we know that this energy for a human body is obtained by an important process of the human body called metabolism. The metabolism is a process in which energy, chemical energy of the food which human beings take is converted into the mechanical energy and the heat. So, if you have to see that in which way a given work can be organized, so that worker can continue to do the job and is able to carry out the job without need of much break, and even if the break is required, how long break should be given, but all that will depend upon in which way the chemical energy of the food available to the operator is converted into the mechanical energy and the heat, and this is achieved by the metabolism process. This is the process in which the chemical energy of the food is converted into the heat and the mechanical energy, and a part of the energy which is being generated is used in some of the internal activities and some of the external activities which are done by the human body. This process of the metabolism is similar to the slow combustion process, where the chemical energy is converted into the heat energy and various other gases are also released. A part of the energy generated as a result of the metabolism is used by the body in carrying out some of the internal activities such as the respiration and digestion, and a part of the energy is also used in carrying out the external activities like standing, walking or doing other activities related with the job. So, if the energy consumption for the work is more, he will be requiring very fast this energy conversion process, so that whatever energy is being generated can be consumed in carrying out the given job. Both internal and external processes, the heat energy is generated, and which is usually found greater than that of the body requirement. As we have seen that in metabolism, the chemical energy is converted into the mechanical energy and the heat. So, whatever heat is generated, that amount of heat heat generated is generally found greater than that of body requirement, and that is why the heat generated by the metabolism process should be dissipated to the surrounding, to the environment, and therefore, extra heat is dissipated by the body to the environment by the different modes of the heat transfers such as convection, radiation and evaporation. So, the heat loss by the different modes of the heat transfers help the body to maintain its temperature constant when work is carried out. Since the different amount of the energy is required in carrying out the different types of the job, therefore, while the job is done, the amount of heat generated also varies with the nature of work which is to be done. The physical activities of the human body which are associated with the contraction of the muscles need energy. Whenever a job is carried out, that the forces are applied to carry out the job, those forces are applied with the contraction of the muscles, and for the contraction of the muscles energy is required, and this required energy is supplied by the glycogen. This glycogen is used to produce the energy through a chemical process, and when this process is carried out, it results in the lactic acid also. So, this lactic acid is considered to be harmful for the blood, and this lactic acid must be dissipated regularly while job is being done. So, dissipation of the lactic acid also takes place through a chemical process in which carbon dioxide is generated and the water is produced. So, for a conversion of the lactic acid continuously during the work, oxygen is required, and when oxygen reacts with lactic acid, it produces carbon dioxide and the water. So, for continuous consumption of the lactic acid and to avoid its accumulation in the blood, it is necessary that it is dissipated continuously when work is done. So, and for that the lot of oxygen is required, which should be supplied continuously by the blood to the lactic acid, so that it is dissipated continuously. At the start of any activity, muscles use the glycogen which is already available in the blood, but over a period of time when the glycogen is consumed, these nutrients are depleted in the body, and in that case the body needs the replenishment of these nutrients. These nutrients which has been consumed while work, during the work, these should be replenished again, and the amount of the glycogen available initially decreases gradually, and the decreased amount of the glycogen should be replaced also, and when this reaction is carried out, it results in energy, and at the same time lactic acid is produced, and for which for the continuous dissipation oxygen supply is needed. When there is a little or very light work is carried out, whatever lactic acid is generated, that is continuously consumed, and therefore no major amount of the lactic acid is accumulated in the blood. So, while doing the light jobs, the amount of the lactic acid generated in the blood is not found much, and it is consumed continuously or dissipated continuously with the available amount of the oxygen in the blood. If the activity is severe, it will require more amount of the oxygen for continuous consumption of the lactic acid generated in the blood. If it is not consumed continuously, the worker may start feeling fatigue, and after some time his sensations also may stop. So, while carrying out the extra heavy job, the extra amount of the oxygen is normally supplied by the blood through the flow of by the blood in which the blood flows through the cardiovascular system. So, excess amount of the oxygen is required, then excess flow of the blood is also required through the cardiovascular system. Although the body adjusts itself to fulfill the increased amount of the oxygen by increasing the breath rate to bring the more oxygen into the lungs, and thereby increasing the heart rate, and by increasing the heart rate to pump more blood through the cardiovascular system. So, if the heavy work is carried out by the worker, he will be requiring more amount of the oxygen for continuous consumption of the lactic acid which is generated in the process. So, this extra amount of the oxygen is supplied by the increased flow rate of the blood through the increased heartbeat rate and the increased breath rate. When breath rate is increased, more oxygen goes into the lungs, and from the lungs oxygen is picked up by the blood which is flowing at a higher rate due to the higher heart beat rate. And in this way the oxygen which has been picked up by the blood through the lungs, it is delivered to the muscles where it is required. So, from the heart, blood is pumped through the lungs where it picks up the oxygen supply, and later it delivers to the muscles where oxygen is required. So, increased breath rate provides the increased amount of the oxygen to the lungs, and where oxygen is picked up by the blood at the lungs and it goes to the muscles where it is required, and the increased supply of the blood or increased flow rate of the blood due to the increased heartbeat rate makes available the required amount of the oxygen to the muscles where it is required. So, for the works which need this amount of energy in such a way that whatever the lactic acid is generated during the work, that is continuously consumed by the available amount of the oxygen under the normal heartbeat and the breath rate rates, where up to certain moderate rate of the work, the heartbeat rate and breath rate normally adjust in such a way that they provide the sufficient amount of the oxygen to perform the physical task over a long period of time. So, up to certain amount of the energy consumption, the breath rate and the heartbeat rate provides the desired amount of the oxygen, so that whatever lactic acid is generated, that is consumed continuously. However, if the physical activity is too severe, then the amount of oxygen delivered to the muscles may not meet the requirement which is required to consume the lactic acid which is being generated by the metabolism process, and therefore lactic acid may start to accumulate in the blood. So, once the accumulation of the lactic acid starts, the operator may start feeling fatigue, and after some time his sensations may also stop. So, if the lactic acid continues to accumulate in the blood due to the continuation of the activity, then muscles will eventually cease to respond, and this is certainly not a good condition when the lot of lactic acid is accumulated in the blood, and which ultimately leads to the situation when body cease to respond to the activities which are desired. So, under such conditions the extra oxygen is required to be supplied. In such cases, the activities are which are too severe, and the body leads to a situation where it stops to respond, and then under such conditions activity should be stopped and additional oxygen must be supplied to remove the accumulated lactic acid. And under such a severe working conditions, heart beat rate and the breath rate are not normally able to supply the required oxygen, so that the heartbeat rate and breath rate can settle back to the pre-work level when work is stopped, but rather it slows down gradually until the borrowed oxygen is replaced. So, when the body responds to body stops to respond, the extra oxygen must be supplied from the outside, so that the accumulated lactic acid can be consumed and it will not be consumed automatically just by stopping the work. So, some amount of the extra oxygen must be supplied under such conditions. We know that the body always needs energy for carrying out the internal and external activities. So, when there is no external activity is being done by the body, still some amount of energy is required by the body to carry out certain activities, internal activities such as breathing and the digestion. So, the metabolic rate which is required just to maintain the body in an inactive state is termed as basal metabolism. So, this basal metabolism is corresponding to the process of the transformation where chemical energy is to be converted into the mechanical energy and the heat energy, and the energy required is such that it is just sufficient to maintain the body in inactive state. So, that the metabolism is termed as the basal metabolism, although the rate of the basal metabolism depends upon the weight, height and the sex of the person, but the average basal metabolism rate for adults usually found in a range of 1500 to 1800 kilocalorie per day, that is found about 80.85 watts. So, as a person performs any physical work, there is a rise in energy expenditure from the body as compared to that at the rest. So, we know that whenever work is carried out, additional energy is consumed in carrying out the external activities, and that the extra energy required for carrying out the job is termed as the work calorie or the work cost. This is also termed as energy cost of the work. What is the energy required for carrying out the given job? So, now we will see that when different types of the jobs are carried out by the human body, in which way and what amount of the energy is carried out by amount of the energy is consumed from the body when the job is done. So, the energy cost or the work cost is different for the different physical activities, because the energy required for carrying out a very simple and light jobs will be less compared to those jobs which will consume which will require a lot of force and excessive amount of the energy in their performance. For example, when person is sitting, he consumes about 1.6 kilocalorie per minute, while in a standing position he consumes somewhat more amount of energy, that is about 2.2 kilocalorie per minute. Likewise, if we compare for male and female, when work is carried out of the different categories, like for the energy consumption or energy cost for carrying out the light jobs like typist or hands at rest, the energy required is about 2.4 to 2.7 for male, while for female it is 2 to 2.2, somewhat more the works which require somewhat more amount of energy, like mechanical engineers moving around the shop floor or the bus driver controlling the vehicle as desired. Here the male will be consuming energy about 3 kilocalorie, while female will be consuming energy at about 2.5 kilocalorie per minute. Somewhat heavier work like fitter, housewives and butcher will be for males it will be coming it will be about 3.6 kilocalorie per minute, while that for female it is 3 kilocalorie per minute. So, if we see the workers who are working in coal mines and agricultural fields, they will be consuming the energy at the rate of about 4.2 kilocalorie per minute. So, if the severity of the work increases, the energy consumption also increases, but depending upon the gender of the person, here the more energy is consumed by the male compared to that of female counterparts. So, energy required for carrying out a job depends upon the nature of the job and the forces which are required when the job is to be done by the worker. At the same time, the gender of the person, age, height, etc. also will affect the amount of the rest needed by an operator during an operation is related to the average energy cost of the work. We know that an operator can deliver the energy only up to certain rate without need of any rest, because if the work energy consumption is too high, then it will lead to the accumulation of the lactic acid in the body, and in that case body will require rest to dissipate and for dissipation of the accumulated lactic acid. So, how long work should be continued, and then after that how long break should be given to the worker, that to a great extent depends upon the energy cost of the work. Therefore, the amount of rest needed by an operator largely depends upon the energy cost of the given work. Normally, the energy cost the cost of the energy for a given work up to 4.5 kilocalorie per minute is considered as a upper limit of the energy consumption which a worker can deliver without need of a rest. If we accept the ceiling of 4.5 kilocalorie per minute as a desirable limit of the average energy cost of the work, then this is the limit which a worker this is the limit of the energy which a worker can deliver continuously without need of a break. Activities for which energy cost is found greater than this upper ceiling energy limit, that is 4.5 kilocalorie per minute, the rests are allowed so that the body can recover by consuming the accumulated lactic acid while doing the jobs which require higher amount of the energy during their performance. And to calculate the way by which the work should be organized, how long work should be continued, and then when break should be given, or how long break should be given to the worker so that he can recover and he can restart the work. Normally, two methods are used to estimate the rest period. These are the Murrell methods and the Muller's method. If you see here, according to the Murrell method, the rest R divided by T is equal to K minus S divided by K minus 1.5. This is one typical equation which has been proposed by the Muller for calculation of the rest period compared to the total time required, where R stands for the amount of the rest period needed by the operator so that the accumulated lactic acid can be consumed and he can recover from the fatigue. To start the work once again, T is the total working time in which work is done, and thereafter means it may be 1 hour, it may be 4 hours depending upon the work period, and K is the energy cost of the work, the amount of energy which is to be delivered by the worker for carrying out the given job, that is in kilocalorie per minute. If the energy cost of the work is more, then obviously the rest period will also be more. S is the acceptable upper energy limit cost of the work. Normally this acceptable upper energy limit cost of the work is found to be 4.5 kilocalorie per minute. In this equation, if we see, the 1.5 refers to the basal metabolism rate, which is it is the energy which is required for carrying out the internal activities of the human body. So, here it is the equation in this equation which you have seen earlier, the 1.5 is approximate amount of the energy which is consumed by the worker during the rest. And if we consider it as a if we adopt the 1.5 kilocalorie per minute as a value of S, then the units if the units of S and K are put in watts, then the said equation can be written as following. Whatever equation we have seen in the previous slide, that is corresponding to the case when the values for the energy cost and for that is S, that is the upper acceptable energy limit is and the basal metabolism rate is considered in kilocalorie per minute, and if the units of the S and K, that is the energy consumption while work is worker is at rest or while work is being done. So, the energy cost of the work, if these two parameters are taken into the watts, then the above equation can be also written as R by T is equal to K minus S divided by K minus 100, where the significance of all the parameters in this equation 2 is also same, except the difference is that that S and K are taken in watts, while R and T are in minutes as before. R refers to the rest period, T refers to the total work duration. If we consider an example where the work cycle of the 60 minutes duration and the energy cost of the work is 5 kilocalorie per minute, then the time of the rest can be calculated using the said method in as following. Here we can use the same equation like R by T is equal to, here K refers to the 5, that is the energy cost of the work, and 4 is the upper acceptable energy limit, and 5 minus 1.5 is the basal metabolism rate, that is 1.5 kilocalorie per minute is the energy consumption of the worker when the body is at rest. And using this equation, if we see that it comes out to be 1 by 3.5. If we solve this equation for a duration of the 60 minutes, then the rest period comes out to be the 60 into 1 by 3.5, and which is approximately 16 minutes. It means that the energy cost of the work is 5 kilocalorie per minute, and the acceptable upper energy limit is 4 kilocalorie, and the basal metabolism rate, that is the energy required by the worker at rest, is 1.5 kilocalorie per minute. Then the rest period for a work cycle of the 60 minute comes out to be the 16 minutes, and after the 16 minutes of the rest, the worker should again start the work for 60-minute work cycle. The Muller method is the another method for calculating the rest period, and very effectively used in organization of the work, but there is a difference in this method. This method is significantly different from the Murrell's method, in which the energy cost of the work and upper acceptable energy limit and the basal metabolism rate is considered to calculate the rest period with respect to the total time of the cycle. Muller's method is the another method which is used to calculate the rest period and to find out that how work can be organized effectively so that worker can continue to do the job without excessive use of the body and a need of the unnecessary rest. So, according to the Muller method, it assumes that an average man is considered to have energy reserves of 25 kilocalorie, and these energy reserves are not used until the energy consumption of the work goes beyond a certain limit. So, according to this, as long as energy requirement of the job is below 5.5 to 5.5 kilocalorie per minute, these energy reserves are not used. These are used only when the energy consumption of the work or energy cost of the work to be done by the worker goes above 5 to 5.5 kilocalorie per minute, and when the job demands exceed the critical level, that is 5.5 kilocalorie per minute, energy reserves will be utilized at the rate equal to the amount by which energy demands exceed by the 5.5 kilocalorie. It means that energy reserves available to the worker are used only when the energy requirement of the work is greater than the certain critical limit, that is 5.5 kilocalorie. If the light work is carried out by the worker which is consuming energy less than 5.5 kilocalorie per minute, then it will not then the energy reserves are not used and he can continue to carry out the job without need of any rest. So, according to this the upper energy acceptable limit is the 5 to 5.5 kilocalorie per minute. The value of this acceptable upper energy limit can vary from one organization to the another, but depending upon the energy cost of the work which is to be carried out by the worker, the energy stored energy will be depleted, and that the rate of depletion will depend upon how much extra energy is required when the job is done. For example, if the 7 is the kilocalorie, 7 energy cost of the work is the 7 kilocalorie per minute, then the rate at which energy reserves will be depleted will be 7 minus 5.5, that is 1.5 kilocalorie per minute will be the rate at which energy reserves will be utilized. So, here if we see an example, for example, energy cost of the job is 7 kilocalorie per minute and the operator during the job therefore using his energy reserves at the rate of the 1.5 kilocalorie per minute, and thus gets exhausted after the 25 divided by the 1.5 equal to 16. 25 represents to the energy reserves available to the worker, and these are used at the rate of 1.5 kilocalorie per minute when the job having the energy cost of the 7 kilocalorie per minute is carried out. Then the worker can continue to do the job only for 16 minutes, and after 16 minutes of the duration he should be given rest, and the rest should be allowed for a period until his breath rate comes to the normal, and his heartbeat rates also are also normalized. At this time, that is the 16 minutes, the worker should begin the recovery period, and the length of the recovery period should be determined by the monitoring the heartbeat rate. There are two ways for deciding that how long break should be given. The time which we have calculated above indicates the time for which the worker can continue to do the job, and after that he needs rest. How long rest should be given, that for that the two methods are used. One is the checking the heartbeat rate of the worker, and he should be allowed to take the rest until his heartbeat rates are normalized. Then our next work cycle should not be started until the rest level heartbeat rate is achieved. Alternatively, the recovery time can also be calculated using the following equation, which shows that u, that is the recovery time, is equal to k minus 1.5 divided by 4 minus 1 into 100. It shows the recovery time in terms of the percentage of the length of the work. K is the energy cost of the job, and the operator here 1.5 is the basal metabolism rate and 4 is the acceptable upper energy limit of the work. Operator may not need the complete rest. He may be given some other job which is consuming some less amount of the energy. Operator may not be required to go completely off the work, but he may be asked to do certain other things which may be consuming less amount of the energy. For example, the person who has been doing the heavy work and consuming the energy at the rate of 7 kilocalorie per minute can recover very well while doing some other light jobs. For example, inspecting or checking the dimensions, because say the light work consuming energy less than 1.5 kilocalorie per minute or 3 kilocalorie per minute or less than the upper acceptable energy limit, those activities and jobs can be effectively done by the operator instead of going for the complete rest from the work. So, to organize the activities effectively, the heavy work is done for the certain period, and thereafter during the rest period or recovery period some other light jobs are done, so that the worker is able to recover. At the same time other activities which are expected from him are also completed in the same period. So, to get the best output, it is necessary that the man machine system must be perfect, and we know that an efficient person can work a nicely designed system effectively only when the man and machine both are installed or provided the proper working conditions, or that is the environment in which they are working. So, to provide the proper working conditions, it is necessary that we are familiar with the conditions which can affect the performance of the worker, and we know that if during the work energy is consumed and at the same time heat is generated, that heat should be continuously dissipated from the body, otherwise temperature of the body will start to rise. So, in which way the heat exchange from the body to the environment takes place, and in which way the surroundings can affect the body temperature and the performance of the work, that should be looked into very carefully. The proper light should also be provided, so that operator can work continuously for a long time without undue strain and fatigue while doing the job. At the same time, when these different systems work in a shop floor or in a work area, they frequently produce the vibrations due to the various causes. These vibrations should be isolated and should be checked, and the system should be designed in such a way that operator performance is not very adversely affected. So, it is required to look into all these aspects in greater detail. First of all, we will see the heat exchange process of the human body and the way by which it can affect the performance of the human body. We know that during the metabolism process, heat is continuously generated in addition to the energy by the chemical process, in which chemical energy is converted into the chemical energy of the food is converted into the mechanical energy and the heat. Whatever heat is generated, that is found to be more than that is required by the body, and that is why body temperature starts to go up. It's if the heat is not dissipated continuously during the work. Human body therefore continuously generates heat due to the metabolic activity. When at rest, adult generates at about 1.5 kilocalorie per minute heat, while under the severe working conditions or during the exercise, an adult can generate the heat as high as 15 to 20 kilocalorie per minute. Since the body temperature of the healthy person is almost constant, that is around 37 degree, and the metabolic heat is generated continuously. So, to maintain the temperature of the body constant, it is necessary that whatever metabolic heat is generated, that is dissipated continuously. For dissipation of the heat continuously from the human body, the surroundings play a significant role. The body is always in process of heat exchange with the environment to maintain its equilibrium temperature. Whenever heat is generated by the metabolic reactions and metabolic process, that heat generated should be transferred to the environment, or when that heat generated is less than the temperature, less than the heat required to maintain the temperature of the body constant, then the heat is transferred from the environment to the body itself to maintain the equilibrium. Heat goes to and from the body primarily by the different modes of the heat transfers, and these main modes of the heat transfers through which heat exchange between the body and the environment takes place are the convection, radiation and the evaporation, and the relative amount of the heat transfer by these three modes of the heat transfer depends upon the type of environment surrounding and the temperature of the human body, or the temperature of the surrounding conditions, the velocity of air, humidity and many other factors related with the environment. So, here the what amount of heat will be transferred by which mode of the heat transfer, it depends upon various factors, and the main and the important factors are the environment, surrounding conditions, air temperature, humidity and the flow of air in the work space. Under the normal equilibrium conditions of thermal conditions, we can see that the whatever heat is generated by the metabolism minus the heat lost by evaporation, then heat can be added or lost by the convection to the body or from the body, and heat can be supplied to the body or heat can be lost from the body by the radiation minus the energy which is consumed in the work. Some algebraic sum of all these is found to be equal to 0. If the energy cost of the work is less, and if we see here metabolism, whatever heat is whatever energy is converted by the metabolism, part of that is used in carrying out the work, and the rest of the heat generated is transferred through these three modes of the heat transfer, in which the heat is always lost by the evaporation, while heat can be transferred to or from the body by the convection or the radiation. The heat exchange process is affected by the air temperature, air movement, humidity and the radiation temperature of the surrounding. We can see here that when the air temperature is too high, about the same as the skin temperature, heat cannot be lost to the air from the body by the simple air convection, and therefore body temperature begins to rise, which activates the sweating glands, and the sweat which secretes from the skin and evaporates from the skin surface by taking the heat from the skin surface, which in turn helps to restore the body temperature. So, if the temperature of the surrounding air is too high, then body will not be releasing the heat by the convection mode of the heat transfer, and under such conditions the body temperature starts to rise, and which this increase in temperature rise activates the sweating glands, and activation of sweating glands leads to the secretion of the sweat from the skin, and this sweat when evaporates from the skin surface by consuming the heat present at the surface, in turn leads to the restoration of the body temperature, and this rise in temperature is counterbalanced by the heat loss by the evaporation of the sweat from the skin of the human being. The air movement, the humidity are the important factors that affect the heat transfer, especially at high temperature. The air movement and humidity are important at a high temperature because they affect the evaporation of the sweat from the body surface. The higher will be the air movement, greater will be the evaporation, and therefore the body will be able to lose the heat rapidly. It is always preferred to work at about 32 degree centigrade wet bulb temperature, and too high, working in too high temperature around 38 or above, the body may feel the heat stroke if the working conditions are too severe as far as the body high working temperature conditions are concerned. So, as we have seen that the heat transfer, relative heat transfer by three modes of the heat transfer from the body to the environment depends upon the air temperature, wall temperature, air velocity and the humidity. In this diagram, we can see here how the air temperature and the wall temperature can affect the mode of the heat transfer or the percentage of the heat transfer by three modes of the heat transfers. So, here the percentage of the heat loss to the environment by these three modes of the heat transfer, that is convection, radiation and the evaporation, and the relative amount of the heat transfer by these three modes for the different the air and wall temperature conditions in centigrade has been shown here. You can see the air temperature for the different combinations of the air and wall temperature. Here we have first combination, that is 17 degree air temperature and 19.5 degree wall temperature. And corresponding to this, if we see when air and wall temperature both are low, here the 50% of the heat transfer to the environment takes place by the convection process, 40% by 40% by the radiation, and only 10% by the evaporation. So, under low temperature conditions, the 50% by the convection, 40% by the radiation and only 10% by the evaporation. While if we see here, when the temperature of both air and wall are too high, that is 35 degree of the air temperature and 36 degree wall temperature, the heat transfer from the body to the environment mainly takes place by here you can see the evaporation. Evaporation is the main mode by which heat is lost to the environment, and that is 100% approximately when the both air and wall temperatures are too high. For reasonably low air and wall temperature, that is 23 degree centigrade, we can see the 70% of the heat loss is by convection, 13% of the heat loss by the radiation, and about 17% of the heat loss by evaporation. If the conditions are just opposite in nature, or you can say the air temperature is 29 and the wall temperature is 52 degree centigrade, then 22% of the heat loss takes place by the convection to the environment, while 78% of the heat loss takes place by evaporation. On the other hand, for 16 degree centigrade of the air temperature and 49 degree of the wall temperature, the 79% of the heat loss takes place by the convection and 21% of the heat loss to the environment from the body takes place by the radiation, evaporation. And so, here we can see the air temperature and wall temperature significantly affect the way by which heat loss to the environment takes place by the different modes of the heat transfer. For the too high air and wall temperature, the heat loss mainly takes place by the evaporation, while for the low temperature conditions, it is the combination of all three, where convection dominates and the evaporation is the minimum one. So, in extreme cold conditions, to maintain the body temperature constant, body reacts in different way. Actually, body reduces the supply of the blood, especially to the hand and feet, so that whatever heat is generated by the metabolism reaction can be conserved. Heat generated in the body by the metabolism process is thus used to maintain the body temperature constant. If the metabolic rate, that is the heat generated, is insufficient to maintain the body temperature, then the shivering begins, and under such conditions the operator may lose the control over the movement of the body parts, and that is why it affects his performance. Performance of worker in general decreases with the increase in temperature in terms of the physical and mental activity. If the temperature is too high and very severe activities to be carried out, that also adversely affects the performance of the worker. And under cold conditions, if the body temperature is reduced significantly, then to maintain the body temperature constant, the blood supply to the hand and skin is reduced, which in turn leads to a situation where the control over the movement of hands and the feet in terms of the speed and accuracy decreases, and that is why the skin, when the blood supply to the skin is reduced, especially at hands and the feet, the skin temperature, significant decrease in the skin temperature leads to the loss in speed and the accuracy of the movement of the hands. So, those activities which require close control over the speed and movement of hands are adversely affected, especially under the low temperature conditions. For example, an operator or the typist typing efficiency is very adversely affected under the low temperature conditions. We can see here that the temperature around 30 to 34 degrees centigrade, his efficiency is typing efficiency is say 100%, and then with the reduction in temperature down to the 16 or 14 degrees centigrade, it is reduced to about 50%. So, here efficiency of worker for those activities where close control over the movement of the hands or the feet is required, efficiency of the operator decreases rapidly with the reduction in the skin temperature. And therefore, to avoid the adverse effect of the high or low temperatures on the human body and his performance, it is necessary that the operators are protected from the excessive heat or the cold conditions, and for this purpose the workers are insulated from the extreme temperature conditions, so that their exposure to the extreme low or high temperature conditions can be reduced. The best purpose means the best way to protect the worker under the cold conditions is to insulate the worker from the environmental conditions. So, whatever heat is generated by the metabolism process, that is conserved and retained within the enclosures which will be used by the worker in form of the clothing. The workers can wear properly designed clothing to insulate the body and lower the metabolic heat loss. So, the metabolic heat is basically used to maintain the body temperature under the cold conditions by using especially designed clothing, which will help to reduce the heat losses to the environment, the heat which is generated by the metabolic process. But under such conditions, it is also important that hands and legs do not come in contact of the very low temperature conditions, because this can be harmful, and these very low temperature conditions can damage to the hands or the legs, which can come across or which will come across the very low temperature conditions. To cope with the hot conditions is found more difficult compared to the cold conditions, because hot conditions also come along with the fire hazards. Protective clothing should not cover to protect the worker from the excessive hot conditions just by complete covering of the human body. Protective clothing should not cover the whole body unless it is very important and absolutely necessary, because heat generated by the body should also be dissipated, and most of the heat is generated by the body is dissipated through the legs and hands. Therefore, effort should be made that the legs and hands are kept open unless it is absolutely important to protect the whole of the body from the extreme hot conditions. So, now I shall conclude this presentation. In this presentation, we have seen the role of the metabolism in effective organization of the work, so that the time when workers should start the rest period and the time for which the rest should be given can be obtained very effectively, so that the work can be done by the operator without undue fatigue, and he can continue the job for long time. At the same time, we have also covered that what is the role of the heat transfer from the body to the environment, and how the workers should be protected from the excessive cold or hot conditions. Now, thank you for your attention, please.